Hello? Hello. Alright. Upon recommendation, this is happening. Um, Not good at it, but, we give it a shot. Wait, this is like nothing. You've probably already done the stuff that I'm going to do at the end of this. But first, we're just going to go through this, the, um, the new stuff. And we're going to do a past exam, which all of you guys have probably already done. I haven't done it because I'm not about that chem grind. Sorry, miss. But at least I'm doing it the night before. Makes sense. So, chemistry, what the? I searched up elements and this came up. It's pretty good. As the group, so one, two, we don't really call the name, what's the word? Allocate these columns any numbers. 1, 2, then 3, 4, 5, 6, 7, 8. We got the non-metals. Boom, boom, boom. We got the atomic number. It's alright. Probably not going to even use that. So this is the entropy. Yeah, this is enthalpy. This is entropy. We'll get this in the exam. We'll get this in the exam. Because how else are we meant to know it? And this is free energy, which is alright. So yeah, this is pretty shit, but let's just write this down. So, if we're trying to find CO2 plus, is that methane? I don't know. CH4. The what's delta H? The enthalpy. I'm gonna say it's the enthalpy. So if we're trying to find the enthalpy of CO2 plus CH4 into CH2, and we got the enthalpies of these equations, and we have to use Hess's law. What do we do? So we want to start just getting up a notepad thing. What is this? And when you open up notes or something, you see something from like years ago. Okay, so we have C. No, so you see this one, carbon plus oxygen into carbon dioxide. See, the carbon dioxide is on the left, so you have to flip the equation, which also means flipping the sign. So, CO2 is on the right, into C plus O2, which means it's 393.5. I wasn't stressed about remembering the units. I've never remembered them. They always appear in the exam. They'll tell you the units. But if you need to know, it's kilojoules per mole. Because in here, how I know, this is enthalpy, kilojoules per mole. Temperature in this one has to cancel out the Kelvin, so this is joules per molecular moles Kelvin. Kelvin moles. I don't know. Because they cross off. This CH4 is on the left, so you switch this around. So CH4 into C plus 2H2. That is 74.6. I'm gonna stuff up on the equation writing. And then 2. This one can stay the same. we're just gonna write negative 484.3. So then you add them up. What does that get you? I'm trying to do it in my head. 5 plus 6 is 1. Whoa. 5 plus 6 plus 3 is 14. So 4 plus 4 plus 4 plus 3. 7 plus 4 is 11 plus 1 is 12. 12 plus 10, 22. Oh, what am I doing? It's just, okay, wait. Take it from the top. So that's 11. Nope. Wait. Let me get rid of all of this. So 11. 14. 17. So you get 474 minus 484.3. And you subtract them. Damn, okay. That's gonna be a negative number. So 11 minus 3, 8. 13 minus 4, 9. 16 minus 8, 8. 3 minus 4 minus 1. Is that how you do it? No, wait. Hold on, I can just count. 374, it's 10.2. Negative 10.2. Don't know what I was doing. So did I put the answer on this? Hess's law. Oh, it was a 5. Where did I get the 3 from? Oh, it was a 5. Oh, wait, I did get a 5. How did they get minus 16? Oh, what am I? Oh, well, that's basically the idea. So, let's just make this a better view for you lot. Alright. So, correct me if I'm wrong. First answer, I think it's just evaporation, right? Sodium chloride, salt, water. We've done evaporation. Empirical formula, simplified. A Use the formula sheet. I'm pretty sure we got. Oh wait, we've done all this. Which of these is balanced? Bro, no. NO3? No. That one's straight up, no. C. 3C, 3C. 4O. 6, that's 10. Zinc, zinc. Chloride, chloride, 2 chloride. This one. Oh, this is good. The energy of the reactants is lower than the energy of the products? No. Exothermic or endothermic? So, endothermic absorbs, exo releases. Yes. So, endo, it absorbs it, goes up. Exo releases. So the answer is C. Well, I mean, I know magnesium, barium are pretty reactive. Potassium's alright. Num num num. What type of reaction? It's not redox. It's not combustion. Decomposition, I would say. Wait, what is a redox? Okay, let's have a look at the images. Oh, it might be redox because it reduces. Oh, something's coming to me. What was that thing that we learned? Something. Oh, entropy? No, that was just entropy. I think this is redox. Reduction? Gotcha. Not really. Don't gotcha. No, then I don't think it's decomposition because decomposition's maybe when there's one on this side and then it goes into many. Precipitation, no precipitate. combustion, no oxygen. So it's redox. You got grams, you got liters. Well, C equals N over V. You got moles, molecular mass, molar. You got the mass. You can find the moles. You can do it like that. Sodium hydroxide at its standard state. Well, what is it at room temperature? Liquid, so I think it's this one. It's definitely not that. Because how does a solid plus a gas go into a liquid thing? So liquid plus oxygen. I'd say A. Oh my god. Oh. This makes you wanna, I don't know. Okay, let's search it up. Oh wait, oh. Alpha decay. Alpha is the helium. Beta is E1 minus. Oh, this is good. But this reminds me of a half-life. What's a half-life? Secret is writing the right equation. So just every time there are some moles, just go M equals M over M, or M equals N equals M over MM. So I believe this is the answer. Yep, 90 minus 1. And I just assume it's that. So entropy. Ice? No. Oh, yes, this one. Yeah, we've learnt that. That's such, what, 15? Shouldn't the harder ones be coming at 15? Oh, no. Oh, there's only 15 marks. Alright, let's go. Oh, wait, yeah, what? Shouldn't that be the hardest one then? Oh well, oh well. Oh, I haven't even checked if it lines up. Oh, you guys can't see the whole question, but I'll just read it out anyway. Um, something anhydrous sodium hydrogen carbonate, right, is used as a primary standard to make a standard solution. Describe a method that can be used to prepare a standard solution of that in a school laboratory. Refer to the glassware equipment. Okay. Well, isn't that just mixing sodium hydroxide, NaOH, I don't know what it's called, and carbon dioxide? I mean, it should be pretty straightforward since it's like the first question of the short answer. So I'm gonna say that, but how would they make it? To just pour into beaker where safety equipment. I have no idea. I'm gonna say it's a solid pouring into this. Butane is one of the components of liquefied petroleum gas. It undergoes complete combustion in excess oxygen. A sample of butane undergoes complete combustion in excess oxygen at 200 degrees Celsius and 1.8 atm, producing 35 liters of carbon dioxide. Calculate the mass of butane reacted. Include a balanced chemical equation in your answer. Anyone want to help? Anyone know how to do this? Anyone know how to do this? No idea. No idea. Man, actually, you know what? I take that all back. I'm gonna go grab my reference sheet. It is very hard to traverse 2 meters. So, on our reference sheet, we have pretty useless stuff. So what we have, so coming from a newbie, you know, I would say excess oxygen at 200 degrees. That 200 degrees is important. Atmosphere, 1.8 atmosphere. Heat capacity of water. If the next question's hard, I'm actually so screwed. That's the heat of combustion. How do you find the M4 bit? Oh, that one's easy. This one's easy. This one's worth 4 marks? Well, which one is it? Yeah, it's MCAT. Is Q in joules? I think it's in joules. Mhm. I'm gonna say it's in joules. So, times it by 1,000. And you got, oh my god, MCAT. Mass, we got mass. Mass of water heated. So do I add them two together? I think I would add them two together. Let's just have a look. Let's do calculator. Calculator app and clutch. Coming in clutch. -4. Nope. -4, 1, 6, 3, 0, 0, 0, right? Divided by 8.38 divided by 4180 and final minus initial plus 23 95. One milliliter equals 1 gram. Okay, so let's just start again. I'm kind of expecting a round number to like give you comfort, you know. Divided by 2.38 4180 plus 23. Hmm. Hmm. It's definitely getting hotter, but why is it negative? I don't know. Aluminium. Oh, Al plus HCl goes into AlCl2 plus H2. AlCl2, put 2 in front of that, and that's balanced. Excuse me? Peroxide. Is that, no, penta, oops, peroxide. I don't know what that is. Fair out. It's tough, but could be the last time I do it. So that's saying something. But no, it's not. I'm not looking at it as, oh, this is the last time I have to do it. Um, I can just bludge it. I still want to do good. I want to give it a shot. Am I confident? I don't know, but I'm willing to give it a go. A red hot crack, and I am currently. Well, that's cool. Any suggestions? You know, it's crazy. Are we gonna give it a red hot crack? Are we gonna give it a red hot crack? When I say hey, you say Chem. Hey, Chem. Hey, Chem. When I say Chem, you say hey. Hey. I'm losing my marbles. Hey. Oh, wait. What have we got so far? How many questions are there to... We're on question 19. 60 marks. 28. Bro. No way. No, I can't even believe this. I cannot believe it. We've done 18. What a balanced reaction between aqueous solutions of barium hydroxide and nitric acid. Well, we know that they're both aqueous, so thank you. 13 grams. Okay. Oh, far out. So, you write the balanced equation. You know what? You could... I say you leave this question to last, realistically. Because if you have no idea, it's a 50-50. Is hydrogen. It's just saying identify the limiting and the excess. You get 2 marks, one for identifying the first and another for identifying the second. But I think I'm okay with that because it's the cheese toasty principle or something. You can only make so many toasties if you have so many, like if you have like an infinite number of bread, you can only make so much cheese toasties with the cheese. Yeah, that one. Yeah, yeah. Okay, we do have a physical copy of this, but I'm doing it online because I didn't do the physical one. Oh my days. I don't think my teacher's expecting much because I haven't handed her anything. But we could surprise her. That would be cool. Calculate the mass. So hydrogen H2 plus I goes to, does it combine? Hydrogen, iodine gas, yeah. So you calculate the number of moles, right? And then you put that over. It should be 2 to something. And if it's not, just say it's 2 hydrogen for 1 iodine, and just say the hydrogen is not 2 to 1. If there's more hydrogen than 2 to 1, then it's hydrogen is in excess. But if it's like hydrogen is less than or iodine is more, then iodine is excess. So calculate the amount. So you just, why is it asking me that? So the amount, you find the number of moles that is away from the ratio, subtract it, you get the moles, and you get the molar mass, and you find the grams. That's only 1 mark. And then you calculate the mass produced. Oh well. Distillation, separating funnel. Okay. I like this question. I had a similar question a while ago. I don't know if it was the exam or the actual one, but I like this question because it's logic and not chemical formulas, which you just can't remember. So, this one, like boiling point, so you know distillation is boiling. It's related to boiling. Funneling, separating funnel, density. So you look at the boiling point, wow, massive difference. So this would be effective. Density, not big difference. Less effective. 3 marks. So I would say 1 mark for saying this, 1 mark for saying that, and then 1 mark for saying which one's more effective. Oh god. Oh! Oh! Beautiful question. Look, number of protons. Shit. 6. Is it 6? I know carbon's 6. Yeah, I think, no, yeah, it is 6. So 6, and then 13 minus 6 is 7. So, how many electrons does that have? I don't know. Does it have 13 electrons? It might. Alright, well, you can get 2 marks off this for just filling out this. Pick this side. So you can either work it out like 1 mark, 2 mark, 3 mark, 4 mark, or 1, 1, 2. That's pretty easy. These, you can get 2 marks so easily on this one. And just YOLO that. Highest boiling point in the molar heat of vaporization out of the smallest molar mass. Hydrogen bonds, sure. Carbon bonds are weaker. Sure, sure. It's like spot the difference. We're not gonna have galvanic cells. Oh, yes. Calculate the enthalpy change during the photosynthesis reaction. Oh, bro, Hess's law is literally the enthalpy change. What? Final products minus reactants. So, you need to write the chemical equation so you balance it out because like if it's like 2 carbon dioxides, you have to 2, and you have to times. Oh, that's for the next part. Then you have to times the thing by 2. So carbon dioxide and water. Don't know what glucose is, so I'll just say it's CO2 plus H2O. Oh, it's like HCH something. 6? I don't know. Amount of energy. How much energy would it require to produce that much glucose? I don't know. I can't tell you. So spontaneous is when H equals um the thing shit when the enthalpy equals the entropy times by the degrees in Kelvin, the temperature in Kelvin. So you have all that, and you work out all that, and then you get it. So that would be easy too. So out of the, what is it, 7 mark? No, 8 marks. You got 6. It's good. Or maybe you could kind of like try and fluke a mark here. That's 7 out of 8. Oh, too easy. Yeah, we know that. Explain using collision theory. Oh, okay. You can get 2 marks out of the 8. Wait, is it one big question? Oh, fuck off. Okay, well, this one. So, let's just identify the factors. We got, bam, temperature, pressure, volume, temperature, pressure, volume, and trying to think. Movement, temperature, pressure, volume. You can get 6 marks if you just use common sense to explain it. Movement in general, like you force the particles into each other, maybe? I don't know. Oh, molar enthalpy, what's that? We did it in class, so you had to like put it over something after you do it. Lose 4 marks there. Okay, so you can find moles, and you can find the mass. That's easy. Easy 2 marks. That's 1 mark. You're not gonna lose it. Okay, so let's grab our calculators to see how many marks we missed. So that's probably like a 2-step equation. So it's out of 70? No. It's out of 65. So 65. No, actually, we're going to do the plus. So we reckon we can get 1, 2. Alright, right now. How many multiple choice? 15. Let's just say we get 10. We're gonna get 10. No, you know what? I'll be harsh on myself. We're gonna get 7. No one gets below 7 in the multiple choice. There ain't no way. Let's say we get 1. Let's say we get 1 again. Let's say we get 3. Let's say we get 2. So we get 4. Yeah, okay. We can say we can get 4. Oh, we'll get 3 on that one. We'll get 2 on that one. Oh, we'll get 3. We'll get 3. Then we can get 2. Oh, you minus 6 from the total. Something. Gives you something. I reckon we can get 3 on that if we, you know what? We got 2. Because we won't know the thing. Don't know. And I reckon we could get 2 there too. I reckon we can get 6. And I reckon we can get a 2 there. So that's 38. 38 divided 38 divided by 38 divided by uh 65 minus 6, wasn't it? No, minus 7. 58. That's 65%. I don't know. I don't know. What we saying? What we saying? I don't know. I got nothing. It's kind of like, what can you do? And this book is staring at me. So this book is telling me to read it, and I am ignoring it for so long. I have holiday homework. I have to. I have to call it. Read this book, Past the Shallows. It's just been sitting on my desk for like the past week, but like collecting dust. It's only 6. Oh wow, it is still early. Oh, you know what? Just ask the chemistry answers at this point. Mm. See, you know, people get worried over an exam. I am not worried because I know I've done all that I could. It's, it's not the be all and end all. It's no problem because I don't know if I want to pursue this subject. Not 100% sure. But yeah. Alright. I think I'm gonna do what I did with my math. Just like play a recording of like some YouTube videos over and over. Also, what I realized, literally like the past, I don't know, a long, not long time. A lot of episodes have passed since someone else was on this. You guys have been hearing my voice for so long. Come on, guys. Where are the integral members at? I don't know. Maybe there'll be one tomorrow. Maybe they're not. Depends how I feel. I'll get home pretty late. Take it one step at a time. Definitely be one on Wednesday, though. I reckon. Because physics is on the Thursday. Oh, yeah. And maybe another one. But oh well. After tomorrow, it's gonna be sweating my ass off. Promise you.